Hello, everyone, and welcome to TechScope News. I'm Tiffani Neilson, and joining me is my co-host, Johannes Beekman. Johannes, this week felt different.
It did, Tiffany. Even last year, most of the AI news was still about demos and model benchmarks. This week, the story is much bigger. We're talking about capital, we're talking about chips, we're talking about satellites, education policy, cybersecurity, and even the electric grid.
And that's the key shift. AI is no longer just software, it's becoming infrastructure.
And once technology becomes infrastructure, the questions change. It's not only what can it do, it becomes who controls it, who pays for it, how reliable is it, what happens when it fails.
So today, we're going to move from the top of the stack to the bottom. We'll start with the money, move through the model wars, then get to satellites, classrooms, security, and power.
And then by the end of this podcast, one theme should be clear. Capability still matters and will always matter, but control is becoming the real battleground.
Let's start with the headline that set the tone for the week. OpenAI says it's closed a 122 billion funding round at an 852 billion post-money valuation. That number is staggering, but I don't think the real story here is simply the number itself.
I agree. The more interesting point is what kind of business would even require that scale of capital? And OpenAI is not describing itself as a niche model provider. It is describing itself as a system with consumer reach, enterprise deployment, developer usage, and enormous compute needs all feeding each other.
And OpenAI is not being subtle about that. The company says it now has more than 900 million active weekly users and is generating $2 billion a month in revenue. And that is an infrastructure scale claim, not a startup scale claim.
Exactly, Tiffany. And the technical piece matters here because OpenAI is also saying durable access to compute is the strategic advantage. And that tells you the bottleneck is not only model intelligence, it's ability to train, serve, and lower cost at a global scale.
So when people hear 852 billion, they should not only think hype, they should think capital intensity, cloud dependence, and the expectation that AI becomes embedded in how work gets done.
Right, but I would add one note of caution. At this scale, growth alone is not enough anymore. To support valuation like that, you need lasting leverage of distribution, infrastructure, and developer ecosystems. That is much harder than just equipping a great model.
So the real question is whether this market consolidates around a few core platforms or whether the value fragments across clouds, chips, applications, and open models.
And my view is that it probably fragments more than people assume, which is exactly why the next story matters.
Microsoft is broadening its AI stack by adding Claude, supporting next generation OpenAI models, offering more than 11,000 models through Foundry, and building more first party capabilities of its own.
And including new MAI voice and transcription models, plus the Maya 200 accelerator on the silicon side, that combination is the point that we're trying to make here. Microsoft wants choice at the model layer, choice at the infrastructure layer, and tight control over cost and performance. If you depend on a single model supplier, a single pricing structure, or a single deployment path, you are exposed.
Well, this is where the industry is maturing. In the early phase, partnerships were about speed. In the operational phase, they become questions of bargaining power and resilience.
And there's a technical reason for that. I mean, different models are good at different things. Some are better at reasoning, some for multimodal tasks, some for lower cost inference, some for enterprise governance. A serious platform provider wants routing, benchmarking, and substitution options.
So the deeper lesson is not that Microsoft is choosing one winner over another. It is that the winners may be the companies that can orchestrate many models, many tools, and many hardware paths.
Exactly, Tiffany. We want options. Optionality is becoming a product feature.
Thanks, Johannes. Amazon says it's launched more than 200 satellites, has another 200 plus ready, plans to double its launch cadence, and expects broader service rollout in 2026. And the business proof point this week is Delta. Amazon says Delta will begin installing LEO on an initial 500 aircraft in 2028, with the two companies talking about a broader integration of AWS, connectivity, AI, and the passenger experience.
And that's why this is more than a connectivity story. Satellites extend the network into places where terrestrial infrastructure is weak, expensive, or unavailable. Once you do that, you're not just connecting passengers, you're connecting aircraft operations, logistics systems, remote workforces, edge devices, and AI workloads that need reliable coverage.
So, this is AI from space, but not in the science fiction sense. It's an infrastructure expansion.
Exactly. It's about global data movement and global service reach. If AI is becoming an operating layer for businesses, then the quality of the network matters again in a very practical way.
And that shifts the conversation from pure model quality to things like latency, resilience, cost, and coverage.
Yes, a system can be brilliant in the lab and still fail commercially if the surrounding network cannot support it where people actually need it. And that's why satellite connectivity belongs in the same conversation as chips and cloud buildouts.
And it also reminds viewers that connectivity is strategic. If you want AI to support aviation, shipping, defense, remote industry, or rural enterprise, then the network is not a side issue. It's part of the product.
Right. It extends outwards, it extends into aircraft, remote regions, moving assets, and eventually any environment where intelligence needs a reliable path back to compute and coordination.
Thanks, Johannes. Not every AI battle is going to be fought in the cloud. One of the biggest AI stories of the past 2 weeks is Google's release of Gemma 4.
Google is calling Gemma 4 its most capable open model family yet, built for advanced reasoning and agentic workflows. Just as important, the models are released under Apache 2.0.
So, why does that matter beyond developer circles?
Because it broadens the market structure. If powerful models can be run openly, locally, and at the edge, then not every serious AI deployment has to live inside a hyperscale cloud. That matters for cost, latency, privacy, compliance, and sovereignty.
And the smaller variants are designed to run offline.
Exactly. Google is explicitly talking about near zero latency local inference on phones, Raspberry Pi systems, and Jetson class hardware. That is a very different picture from the assumption that advanced AI always requires a giant centralized cluster. Open models create room for different deployment patterns. A government agency, hospital, factory, or field operation may decide that some workloads should never leave the local environment. With the right models, they do not have to.
And it opens up a bigger conversation. If powerful models can run locally, then enterprise and governments get more control over data, latency, cost, and even sovereignty.
And that's the key word, Tiffany, sovereignty. Open models and local inference give organizations more room to decide where intelligence lives. It also changes the economics. Some workloads may never need to leave the device or the local edge.
So the AI market is not just becoming bigger, it's becoming more structurally diverse. Closed frontier systems at one end and open local systems at the other.
And for technical teams, that means architecture choices are becoming strategic choices.
Now let us shift from infrastructure to society. Images and videos of the First Lady escorting the first humanoid robot into the White House have gone viral, but this was for far more than just a show. The White House said on March 25th that the First Lady convened representatives from 45 nations for a summit on AI and education, and the event put a humanoid system on stage as part of that message.
The theatrics drew attention, obviously, but the policy signal is the real story here. The official framing emphasized three pillars: personalized learning, humanoid educators as at home tools, and technology plus education as drivers of economic competitiveness.
And that's a major escalation in tone. This is not just about school district technology purchase, it is AI policy crossing into national strategy.
Yes, it is, because education is where long term competitiveness gets decided. If a country believes AI tutors can raise learning outcomes, improve access, and produce more technically fluent workforce, then education stops being a soft social issue and becomes an economic and geopolitical one.
But this is also where the discussion has to remain human. The promise is obvious: personalized pacing, always on support, and broader access, but the risks are also obvious: over reliance, weak oversight, privacy concerns, and the possibility of confusing simulation with real mentorship.
And I would add one more concern, Tiffany. Education is not only information transfer, it is also judgment, social development, trust, and the formation of attention. A system can optimize instruction and still miss something essential about learning.
So, Johannes, what roles should it play and what should remain distinctly human?
Well, Tiffany, AI should help with personalization, tutoring, and access, but judgment, mentorship, and social development should remain distinctly human.
Thanks, Johannes. Another story this week is a very useful reality check. GitHub's own DMCA records show that a takedown notice connected to Anthropic's leaked Claude code repository was processed across an entire network of about 8,100 repositories and then partially retracted the next day.
This is one of my favorite examples of why operational control matters more at system scale. GitHub says the network wide action happened because the notice alleged that all or most forks were infringing to the same extent as the parent repository. In other words, broad action was taken because the control logic was broad.
And that is the lesson. The incident is not interesting not only because source code was leaked, but it's interesting because once the response mechanism kicks in, the blast radius can be much larger than the original mistake.
Exactly. And by the way, this is the same problem we're going to face with agents and automation across the economy. A system can be authorized, fast, and technically correct within its own rules and still create a bad outcome because the context was incomplete.
So when people say we just need smarter automation, the answer is no, not just smarter. We need better permissioning, narrower scopes, better rollback, and more deliberate action gates.
Absolutely right, Tiffany. Intelligence without controlled execution is just a faster way to scale mistakes.
And Apple has confirmed that WWDC 26 begins on June 8th and will spotlight AI advancements at the same time its recent Mac launches heavily emphasized on device AI and local large language model workloads.
And that puts Apple in a very interesting position. It already has what many competitors want: enormous hardware distribution, tight integration between silicon and software, and a stronger privacy narrative than most of the market.
But the unresolved question is the interface. Can Apple define how people actually use AI day to day? Or will it mainly provide excellent hardware for everyone else's AI?
That's the $64,000 question, Tiffany. Apple can clearly run more AI locally, and the M5 systems are explicitly being marketed that way. But the real test is whether Apple can turn that into a defining user experience. If AI becomes the next operating layer, interface control becomes strategic control.
So WWDC matters because it could tell us whether Apple is finally shaping the AI moment or simply accommodating it.
And for a company of Apple scale, that is a very big distinction.
Microsoft says threat actors are already operationalizing AI across the cyber attack lifecycle. And RSAC materials this year put an unusual emphasis on autonomous and agentic systems.
So this is where the slogan AI versus AI becomes useful, but only if we are very precise. Attackers are already using AI to draft lures, translate content, debug malicious code, summarize stolen material, and reduce friction across campaigns. Defenders are using AI for triage, detection, and response, but the real change is not just speed, it is action.
Which is why I like one phrase from the RSAC discussion: trust per action, not just trust at login.
And that's exactly right, Tiffany. One essay from RSAC argues for what it calls a runtime action gate. Before an agent actually executes a tool call or takes a consequential step, the system should ask, does this make sense now? Is sensitive data involved? And should a human approve this step?
Well, that sounds simple, but it is a profound change in security design.
It is a profound change in security design. Traditional software security often assumes a relatively stable application. Agentic systems are different. They are dynamic, tool using, context dependent, and capable of novel change of action. So the place where security really matters is not only at build time, it is at runtime, at the moment of action.
And the model builders themselves are reacting to this. OpenAI just launched a public safety bug bounty focused on agentic risks and also published work on monitoring internal coding agents for misalignment.
Which tells you that the industry understands the problem. The hard part is that monitoring, runtime checks, and governance are not optional add-ons anymore. They are becoming core architecture.
Thanks, Johannes. Next, let's talk about one hard physical constraint on AI growth.
Power?
Exactly. NVIDIA and Emerald AI announced work with major energy companies to build flexible AI factories that can connect to the grid faster and operate as grid assets rather than just passive loads.
And this is a huge story, Tiffany, because it makes the bottleneck absolutely visible. Everybody likes to talk about models and chips, but if you cannot get power, cooling, and interconnection, none of it scales. NVIDIA's argument is that future AI factories should be designed together with energy systems and should be able to flex with grid conditions.
So instead of treating an AI data center as a giant and flexible electricity sink, the idea is to treat it as something more responsive and strategically integrated.
Yes, and that matters economically and politically. If AI demand collides with grid constraints, then utilities, regulators, and energy developers become part of the AI story. And that's a very different world from the old idea that AI is just software that you layer on top of existing systems.
And it brings us right back to the underlying theme of today's news. Once AI becomes infrastructure, it inherits all the complications of infrastructure, financing, supply chains, geography, resilience, and public policy.
Exactly. AI is not just running on infrastructure anymore, it is becoming infrastructure.
So, Johannes, if we zoom out, what do all these stories have in common?
Well, they all point to the same transition. AI is moving from tool to system and from system to infrastructure.
And when that happens, the center of gravity shifts. We still care about model quality, but we care just as much about compute, energy, routing, governance, distribution, and control.
And that is the big story of April 2026. The industry is not only chasing smarter models, it's building the operating environment around them.
And that is why questions are getting harder. Who owns the stack? Who controls the interface? And who sets the rules in classrooms, in workplaces, in code repositories, on airplanes, and on the grid?
Because once intelligence becomes embedded in everything, control becomes the real scarce resource.
Well, I feel that's a good place to leave it. And be sure to join us for our upcoming Green Things Summit taking place virtually on April 23rd. You can register now at iotmktg.com. And thanks so much for joining us for TechScope News. We'll see you all next time. Thanks, Johannes.
Thank you, Tiffany.
Bye-bye.
Bye-bye.
Climate pressure, rising energy demand, electronic waste, and resource constraints continue to challenge industries worldwide. At the same time, AI, IoT, automation, and edge computing Unlock new ways to operate efficiently, reduce waste, and accelerate sustainability goals. At the Green Things Summit on April 23rd, 2026, experts across clean tech, digital transformation, and environmental innovation will explore how intelligent technologies drive measurable impact and what these shifts mean for your sustainability strategy. This full-day virtual event features thought leadership panels, industry keynotes, and interactive Q&A sessions. Be sure to attend, and you can register now free at iotmktg.com. See you at the event.